بسم الله الرحمن الرحيم. Assalamu alaikum wa rahmatullahi wa barakatuh. Today we'll continue our work on the course of deep learning for computer vision. This lecture will be an introductory lecture. We'll talk about, in general, about the concept of deep learning for computer vision. Uh, let's see now, share the slides. The title of this session will be Introduction to Deep Learning for Computer Vision. The main concepts or guidelines of the session will be as you see here. Here we'll talk about the motivation and some topics for warming up and start for you in this course. Also, we'll talk about the four pillars of the computer vision and deep learning applications. We'll start with computer vision, definition and aspects. We'll talk about artificial intelligence, and later on we'll talk about machine and deep learning approaches. Finally, we'll concentrate or direct your attention to the course content that will be tackled in this series of lectures. Now, I think that you have already heard about deep learning, machine learning, AI, artificial intelligence, computer vision, and all these topics. They are very related to each other and cannot be separated to be simultaneous approaches. So, in general, deep learning has been attracted by many aspects of or engineers maybe and applicants in various types of applications. So the deep learning knowledge is becoming increasingly vital for everyone. This means all people all over the world, regardless of the background, whether they are engineers, medical scientists, doctors, maybe in law, in business, in marketing, all these topics, actually these directions of human life are attracted or are can found deep learning application in it. In fact, the human is always thinking and developing. So the design thinking and the human-centered approach to development, innovation, and knowledge growth will cause always developing the deep learning solutions that drive all sciences and improve people's life. In the last maybe maybe 1 or 2 decades, we have witnessed that there was a great development and we can say evolution or revolution or explosion in deep learning applications that has been made. And this was caused by three main ideas or pillars. The first one is the vast amount of data available. As you know that we in the last few years, there was an explosion in the amount of data that is required for transmission, for reception, for storing, and to be processed and tackled with. And also there's a monotonic and increase in computational power algorithms and innovations in this direction. All these topics have led to the need and the requirements for new technologies and for new approaches like deep learning. So what's deep learning? What's deep learning? Let's go now and start talking about the first part or the four pillars of this explosion in information technology and its applications. We'll start with computer vision. Part one, we'll start with computer vision. We go to artificial intelligence. And next, we'll go to machine learning applications and deep learning as a final stage in this, let's say, lecture. Now, what is computer vision? What is computer vision? In fact, image processing and computer vision are very related topics. However, in computer vision, it's a specific field of study where it enables the computers and systems attached to these computers to derive meaningful information from digital images or videos or maybe supporting visual inputs or data. Now, what does that mean? Now, in computer vision, our objective is to work on algorithms that lead to give a decision or action or recommendation based on the visual information received and to process further by computer programs or computer apps without the intervention of humans. Now, it's an in-joke or it's some sort of engineering statement. If AI enables, which AI means artificial intelligence, enables computers to think, computer vision enables them to observe, see, and understand. What does that mean? So AI includes computer vision as a part of it, but not all computer vision applications are included by AI. This means that you can use computer vision algorithms, techniques, procedures to aid AI in order to make this AI think and take actions or decisions, while the computer vision are the tools that are required to make this AI available and feasible for our applications. Okay. Where we can find application on computer vision? Actually, you can find a very large and a wide spectrum of applications on computer vision. For example, in automotive industry, as you hear, in public security, in medical imaging, in traffic flow uh, analysis. In general, if we start by this chart, we can see that we can use computer vision for defect detection. It could be in engineering applications, in industrial applications, in meteorology, can define specific types of materials and methods used for their analysis and to detect types and defects and operative parts of these materials. Intruder detection, we can detect hackers, we can detect by computer vision, we can detect illegal people that try to interact with your system. Also in assembly verification, when you verify that your device is assembled as required, it may be a device, it may be also, it could be, let's say, a sort of software or application in screen reading. So you can find many applications now in the field that can help you in reading the text or in translating text parts or maybe converting the speech into a text, etc. All these applications can be used and depend on computer vision applications. The list is very long, and you can find in computer vision also in robotics, mainly in robotics and for name picking and for any other application. And actually, robotics is a very hot area of implementation of the computer vision applications, in fact. Now, if we talk about artificial intelligence, the second part of our pillars, uh, which is AI. Now, what is AI? AI actually is the theory and development of for computer systems that enables to perform tasks normally. What does that mean? So we can it's an area of research or an area of work where we develop the theory and applications to enable systems to perform tasks normally like humans, requiring without requiring human intervention. This includes the visual perception, speech recognition, decision making, and translation between languages. So you may use the AI tools in order to, let's say, apply a specific visual task, or maybe speech recognition or speech translation, to decide to act or not to act, or to decide how to act according to the input received by the AI software or program, or maybe hardware application, to make decisions like humans, to be intelligent like humans. Now, AI is the big umbrella of that includes a wide range of applications and technologies, including machine learning, deep learning, uh, natural processing learning, also uh, NLP. So, in general, we can say that AI is a very big, wide umbrella that includes almost all the other applications in this field. When we talk about applications, the list seems endless. For example, if we take the Siri application that's on iPhone and iPad, it also you can find similar things on Google that help you by voice commands. You can get specific actions, or search for specific article or maybe website, etc. Or to switch on or switch off a specific application. This can be found in, let's say, a good example is this Siri or Siri application, or AI-based application. You can find also this in Tesla company, the smart automobile, where the cars of this company is very well equipped with AI applications, including let's say speed control, the comfortable furniture inside the car, and how you can memorize the car previous action according to the behavior of the rider or the driver, let's say. So all these things are built in these cars. Also, you can apply or you can find AI applications in Netflix movie services, where you can it can help you in choosing your favorite videos, and to save these options for you for the next session, or for the next let's say movie session, or when you want to go back and continue at a specific um, point or behavior according to your choice. Similar things can be found in the Nest Google Net, in the Google on the Net. Nest is a combination of smart algorithms that can save energy for your device, and saves, or it can investigate your behavior and schedule accordingly to help you work longer time on your system or on your device without losing power for a long time. Uh, Another application is the Amazon, which is called Alexa enabled voice shopping. You can act using your voice using this Alexa application to order and to pay for a specific box, or for your own what you want exactly to buy, and to shop to a specific location or place. All these applications also can be found in other applications, as you see on the right hand side on this chart. Here we can find it can be found in business, in autonomous mobiles, in cars, and in new services. You can find in different applications like in tourism, in social media, in law, in education. For sure, as you see here, we can use AI applications in our lectures, and we can apply it very explicitly, very simply to provide good lectures, as you see here. You can find artificial intelligence in health, in smartwatches. Sometimes when you, for example, sit down with having your watches, and maybe for a while, you'll see a notification that you need to, let's say, to practice and to make some physical motions after sitting for a long time. All these applications are supported by AI-based applications and softwares. Let's go now to machine learning. What is machine learning? It's a push further. It's an area of AI, sub-area of AI, where the concept of a computer program uh, can learn here. The software itself can learn and take new data, new features, can be uh, fed into the software or program, and it will help in making decisions and actions without the intervention of a human. So it can act as an independent application. Here, it requires complex algorithms and source codes that are built into a computer, and they are all used after training. For here, we need to train the system or the software, and it can make predictions around the data that has been used in the training. So when you fed a new data, it will use the trained data to get actions according to the features collected and information collected from the trained data. It helps to make predictions for new data that when it will be fed into this machine learning system. So as you see here, it can be used as a standalone application. It can also be useful because the data processing and used algorithms are built in a manner that to imitate the way that humans learn, gradually improving its accuracy. As you know that we, from our few early days when we were babies, and we later on grow up, and we learned a lot of things gradually and step by step to improve our accuracy and our decision making facilities, and this is also used in machine learning in order to improve its accuracy and its performance during the testing of the new data coming from the sounding board. Now, the list again is very long when we talk about the applications or algorithms of ML. Here we'll start, let's say, with learning or linear regression, a very simple machine learning application. And then we'll go to the little bit advanced logistic regression, and then go to LSTM. These are basic ML algorithms that we'll talk about later on. Then we'll go to some advanced tools or techniques like decision trees. We'll take random forest. We'll talk about reinforcement learning, learning from errors or from mistakes. Then we go to k-means algorithm, nearest neighbor algorithm, enhanced artificial neural networks, and naive Bayes. All these techniques are used in machine learning, and they are mainly based on neural networks, that artificial neural networks that that we are going to talk about later on within this course, and they are modified tools and techniques that are based on artificial neural networks that mainly build the machine learning algorithms in general. So in machine learning, I'm going to use a framework to accelerate solution development, such as, in fact, there are resources that can be used for machine learning, and the very well known and very popular in this direction are the TensorFlow, PyTorch, and also we do not forget to mention MATLAB, because in MATLAB there are very strong toolboxes regarding machine learning, deep learning, and AI applications, and computer vision as well. These are the very well-known and very popular development solution tools. that help in making our design sufficient and powerful in these directions. Applications of in on ML, you will find a lot of applications. Repeating the applications that were used maybe in the previous computer vision and artificial intelligence, because there is a big overlap between these things. We'll find, let's say, here intelligent agents, natural language processing, etc., virtual assistant. Also, we can find in e-commerce, here as you see here. Okay. Also, we can find in healthcare when you have maybe watches we have in on your mobile. You will find a lot of applications. You can also find in domestic applications of healthcare for old people. You can find there they can help in drug discovery, disease diagnosis, robotic surgery. This is a very important tool when we can apply. Sometimes humans cannot do specific actions. They can be done by the help of robots or robotic surgery applications. In social media also we can find filtering spam, for example, when you have in your email you get some spam emails. They are automatically filtered as spam with a good accuracy, and it will help in avoiding noisy messages and noisy sources like, let's say, advertisement, let's say, messages or notifications that you not well actually to see all the time. In cars, in transportation, you can see in air traffic, in airports. All these things can be found, and they are based on machine learning applications. The list is very long and seems endless. And next we'll see in details and we'll talk about these applications on time. Now, in machine learning in general, there's a life cycle that mainly can be divided into 3 stages. Stage 1, let's see this. Let's go to the chart on the left, on the right. Step 1, step 2, and step up to step 4. Here, this is related to data capturing. This part is related to the data capturing, gathering data preparation. We can divide data into specific classes, for example, into specific meaningful divisions, data wrangling and analysis of data. We prepare all this data and provide it to the system. We provide to the model, the machine learning model, where we train this model according to the input data used at these stages. Next, when we get the model trained, we get finalized step. We go to the stepping we step further to the model testing. We test the model by applying external data from outside the data that we already gathered before. And when we are sure that if things are okay, we go to the development stage where we here can provide the software or this let's say system and on a commercial level and propose that it can be used by others very safely. Let's go now to the deep learning definition. What is deep learning? In fact, in deep learning, it's a machine learning tool. However, it's a subfield of machine learning. Now, concerned with algorithms inspired by the structure and function of the brain called artificial neural networks. So in deep learning in general, it's an extension of machine learning with higher facilities, with stronger and better performance, and with higher requirements regarding the memory and computational cost, with an objective or a target that we get better performance And in fact, it repeats, or let's say it tries to take use of the brain structure. Let's go to this part. And this part is related to the, specifically to the artificial neural network, which is based on the, it tries to imitate the human brain actions and operations. Well, for sure, we'll take more time to understand all these things. Now, this is a very simple demo. On, as you see here, we have number 2 as a handwritten, let's say, image, and you will fit this image into the neural network. This is maybe deep learning or maybe machine learning, depends on the number of layers and the complexity of the system and the performance of the output. And as you see here, as we go further inside the system, in this neural network, we'll go to one of the digits here on the right. And as you see here, we could recognize using the system that this number, this handwritten, is the printed or the usual number 2. The list of applications is very long. However, let's say now go to another application. Here we have a classification system or deep learning system. Here we have the input different animals like dogs, cats, and when we fed this to the system is, or what we mean by the system, the deep learning system. The system has been tested for sure. Before that, we have trained the system on a very large data set of animals of different types, dogs, cats, etc. And now having this network, we can recognize that this or classify this input, in this case, is a dog, is not a cat or is not another animal. So we learned the system how to work, and we get a system that can be used to classify animals into specific classes, maybe into cats, dogs, etc. It could be also to subclasses, different types of cats, different types of dogs, etc. Another application of deep learning systems, as here we can recognize and classify all objects moving in this video. Here, as you see here, we have a car, we have a person, maybe we can give him an ID, name, according to the used data set in the system. As here, we also can add, if you follow this car, when the car is moving, we have the accuracy or the probability of having this as a car, as if you can capture. I try to stop this video. Let's go back. It's 0.999 probability that this is a car. So it's almost 100% probability that this is a car. And here we have traffic lights as at the top here. So in deep learning, you are dealing with moving objects, or maybe with movies, having or moving objects, and we can recognize and classify all these with a surrounding box, a bounding box, that this is a car, this is a traffic light, this is a man, this is a street, this is a building, etc. Another application of deep learning is also can be found when this running dog, we can classify the dog and the surrounding objects like buildings, sky, grass, etc. All these applications can be found very easily or can be used, and there are a lot of applications on it in deep learning methods. Another application is this dog robot. It tries to open the door. It has mechanical parts, computer vision parts, and the deep learning, central deep learning unit that helps to make it operate and work and move properly without mistakes as much as possible. So what is deep learning? As we said before, it's a type of machine learning in which a model learns to perform various tasks like detection, classification, segmentation. So our main objectives in deep learning to perform operations like detection of objects, detection of faults, of people, cats, dogs, etc., to classify these objects into different classes, and maybe to segment. What we mean by segmentation here, to segment that this, for example, this person 1, person 2, and this is a car, this is a traffic light, etc. This can be done directly from images, from videos, from text maybe, and also from sound. As here we have an engine joke, that where we talk about machine learning, and it's a strong definition. And the person here is looking at his brain as being as a neural network, and he's, wait a second, is that me? So he's very surprised that this is what is going inside our brains. Of course, DL is usually implemented using artificial neural networks as ANNs. However, in deep learning, we can extend furthermore and go to other applications. In neural networks, in machine learning or neural networks, the number of layers that are used in ANN is a little bit small, maybe 2, 3, up to maybe few layers. While in deep learning, we may go up to hundreds and get better performance. So this means that we need to go deeper and deeper into our application or in our network. Now, why we need deep learning? Here we can see a long list of applications like automatic feature learning, handling large and complex data, improved performance, achieved state-of-the-art performance, because in deep learning we are achieving very higher performance than when we are dealing with machine learning, AI, and in computer vision, classical methods, I mean. Handling nonlinear relationships. The brain can uncover nonlinear relationships. This is not easy for other applications. It also can handle structured or unstructured data. So we can have a video having images, moving images, let's say text, talking persons, and all these data can have structured and unstructured data, like images, like random data, and you can handle it using deep learning. Also in deep learning, you can apply predictive modeling. So you can predict what the next step will be for future. You can upgrade or update or maybe improve and recover the missed data using deep learning. You can also handle sequential data, the same thing as we have seen in videos. You can also get scalability and generalization. For example, for example, the Google Net can help in classifying images, input images into around 1,000 applications or 1,000 classes. Now you can use this Google Net, for example, in your own for your own task. Let's say you want to classify as an engineer PV panels, photovoltaic panels, into operative and non-operative different classes. You can just apply transfer learning of this model, and you can just drag and drop this model and modify very simple and very short and quick actions can be applied to the Google Net, and it's already ready for your application and for your own data set and for your own training. It's one of the very strong features of the deep learning networks or applications. Now we repeat the same applications in deep learning, but with better performance. As see here, when we deal with deep learning, if we have the amount of data on the x-axis and the performance in accuracy in precision of defining the required task or class. As we increase the data, the machine learning algorithms are not increasing linearly. When we get very long or very large or huge data, machine learning will stop improving the performance. And on the contrary, for deep learning applications, we can see that here, that by increasing the amount of data for used in training, the performance will be better than for machine learning applications having the same size of the data. So when machine learning stopped working at this point, deep learning still be able to continue and give better performance. And it's one of the main achievements in deep learning over machine learning. This will be also discussed in details later on. Uh, Here a type of comparison. Let's move my video here. As here in comparison between deep learning and machine learning, here we have factors, deep learning and machine learning. The factor here, data requirements. That deep learning requires larger data, so it's a negative, while machine learning can work easier for lesser data. The accuracy in deep learning is higher. Let's have a pen here for the accuracy. Provides higher accuracy than for machine learning. For the training time, for deep learning, the training will be longer and longer when compared to the machine learning. Of course, this will be at the expense of better performance. Hardware dependency or requirements for hardware. In deep learning, we need GPUs, graphical processing units, while we need more and more proper GPUs. While in machine learning, we can train on CPU or maybe on doesn't require actually to work on GPUs. Simple computer, domestic or let's say personal computer can be useful in training such systems. In the hyper-parameter training, tuning, now number of parameters that are required by the deep learning system is much higher than when dealing with the machine learning. So as you hear, the requirements in machine learning are lower. The requirement by the deep learning is higher, but the performance is much higher when we deal with the deep learning. I think this is the main advantage behind using deep learning. Recap. As you see here, we have all topics are very related to each other. We start by artificial intelligence, machine learning, and then deep learning. Deep learning is a part of machine learning, which is a part of the artificial intelligence, and it may also interact, the AI may interact with computer vision partially. Maybe computer vision, it's a part of the AI, but not all AI are not all computer vision are applicable for AI for sure. Now, and AI may contain other topics that rather than computer vision. As you see here, we have artificial intelligence as the big umbrella. Then machine learning is a part of it. Let's have a pen here to better show this. So we have here machine learning as a part of the AI. Then deep learning is a part of the machine learning. Let's have another pen color. Computer vision interacts with machine learning and with deep learning by this part. Finally, if we have the intersection between all these things, we may get this red part, which represents the deep learning, that combines all the topics of machine learning, computer vision, and artificial intelligence. And this is our class actually will be focusing on machine learning for computer vision. The course will be containing few CV, few ANN concepts, and for sure image-based DL models. We are going to concentrate only on deep learning for computer vision, which means for image-based applications. And this is very hot area of and a very attractive area nowadays in all aspects of human life. You can go to these links and you can find very good explanations and videos that can tell you about uh, the the topic. And that's all talks. And I hope that it was enjoyable for you and waiting for you for the next lecture. See you next.